It's day 3 of Advent of Code, and I'm so excited to see what the next problem has in store for us. This puzzle is all about items inside of rucksacks, and in case you're unfamiliar, a rucksack means a backpack. But in this case, really what it means is a string, and the items are characters. So what we want to do is compare the first half of the string to the second half of the string, and then see which character they have in common, and then we're going to convert that to kind of like a character code, which they're calling a priority, and then we're going to add those all up. So we'll start by pasting in our sample input, and then our game plan here is basically going to be to find the common item for each string, and then convert that to the item code or the priority, and then add all of those up. Just like in the previous 2 puzzles, we're going to start with a dot split on our sample input to convert this to an array of strings. So now we'll just grab this first string as our sample rucksack so that we can start developing functions for finding the common item and then converting that item to a priority or a number. So to find the common item, basically we're going to start by dividing the string into its first half and second half, and then we're going to find which characters that exist in the second half are also in the first half. There really should only be one of those, so that's what we're going to return at the end of this function. To divide the rucksack in half, we're going to start by finding the index of the halfway point of the string. We know that there should be an even number of characters for it to be able to be divided up into halves, so we're just going to say rucksack.length divided by 2. And now we're going to go right into a destructuring assignment, which we saw before, and we're going to use .slice for each of these. For the left half, we want it to go from 0 to the halfway point, and remember, it will not include the character at half index, which is good, that's what we want. And then for the right half, we want it to start at half index and then go all the way to the end, and we actually don't even need to specify the end index here, it'll just assume we want it to go all the way to the end, so that's nice. So now let's just test to see if this is working. We're going to use the property value shorthand we saw in the last video just to see what the first half and second half are. And that looks good. It seems like we've divided them up in the way that we want to. Let's keep going. To find which items the 2 parts have in common, we're going to start by converting the second half into an array so that we can use array methods on it. I'm going to start by using filter, and this is basically a method that's going to take what they call a predicate as a callback. So essentially that's a function that's just going to return true or false given the item as an input. And then anything that returns true is going to remain in the array. Anything that returns false is going to be removed from the array. And then we're just going to use the .includes string method on the first half, which is going to return true if the item is in the first half and false if the item isn't in the first half. And now when we run this, we see that there's only one common item, which is good. That's what we're looking for. But we could be a little more efficient about this. The problem is that when we use .includes, it's actually going to go through the string one character at a time to see if we've found the item we're looking for. So that's a bit inefficient. We would ideally like to use a method that's just going to execute in constant time and just tell us right away true or false. It's in there or it's not in there. So what we're going to do is before we even execute this part of the function, we're going to convert the first half into a set. A set is a data structure that's great to use when we don't care about the order of our items, but we want to easily be able to tell if something is in the set or not in the set. It's also good when we don't care about repetition, but that's not really part of it for this problem. You can think of a set as basically being like an object where the keys are the items and then the values are just true or false. It's in there or it's not in there. So the conversion to a set is still going to take linear time, but we only have to do that once, as opposed to the .has, which we're doing for every item of the second half, and that part's executing in constant time, which is nice. Now we actually just want the single common item here. We don't want an array containing that item, so we could just say common items at 0, but we can actually do a bit better than that. We're using .filter to get an array of all the common items, but there's actually another method that would be a better fit here since we're just looking for one item, and it's called .find. So it works very similarly. It's going to take a predicate, in other words, a callback that returns true or false, and it's just going to give us the first item for which that callback returns true. And in this case, since there only should be one item that returns true, this is perfect. And there we go, it's giving us the item we're looking for. Great. So we have our find common item function. It seems to be working. Let's move on to the next function, which is going to convert this character into a number. To convert the item to a number, we're going to start with the character code at method, and it's going to convert it into an ASCII character code. So by default, a lowercase a will have a character code of 97, but we actually want the lowercase a to have a character code of 1. So basically we can start by just subtracting 96 from this value. So now we're getting all the right codes for our lowercase characters, but we're going to have to do something a little bit different about our uppercase characters. So we'll use a very simple regular expression to test if the item is lowercase. If it is, then we'll do the character code minus 96, and if it isn't, we'll do some different math. So just starting with the character code, we're going to test this with capital A, and we find out that it has a character code of 65. If we wanted this to reset to 1, we could just subtract 64 from it, but we actually want it to start at 27. So we'll subtract 64 and then add back on 26, which is basically the same as just subtracting 38. Great. So now we're getting the right values from this function, but we could make it just slightly more dry. Right now the ternary operator is right out front, and then based on the response to that, we're deciding whether we should take the character code and subtract 96, or take the character code and subtract 38. But we know in either case, we're going to take the character code and we're going to subtract something. So I want to rearrange this so that we're repeating ourselves a little less. Great. So now we're just saying, take the character code, and then depending on whether it's lowercase or uppercase, either subtract 96 or 38 respectively. Nice. Now that the two functions are working the way we want them to, let's apply them to our whole array. So we'll start with the rucksacks array, and we want to convert this to an array of common items. So we'll use .map for that with our find common item function as our callback. And then we want to convert that to an array of item priorities. So we'll take our common items array and then use .map with the getItemPriority function as its callback. And now we can see the output is what we expected. These all match the values from the problem description, so this is good. Now the only thing left to do is to add them all up, and this part is something we've done in all of the challenges so far, so it's probably becoming familiar. We want to add them all up, we're going to use .reduce. Great! We're getting the value we were looking for. That's the same one that we saw in the puzzle description, so that's a good sign. I'm going to assume we're probably going to want to do this sum operation in the second half as well, so I'm going to think ahead and assign this reducer to a variable. We'll try submitting this with the actual puzzle input in just a second, but before we do, there's just something I want to comment on. Since we're only using each of these arrays once anyway, we probably don't need to store them in a variable, so we can just consolidate these all together if we wanted to. And now it's still pretty readable. We see that we're mapping to the common item, we're mapping that to the item priorities, and then we're adding all of those together. And it looks nice and concise and readable and good. Okay. Now that we have that all done, let's try submitting this with the actual puzzle input. Just like on the previous days, I'm going to paste this code into our browser console with this asynchronous function at the top that's going to fetch our puzzle input directly. But once again, you can get the puzzle input however you want. If you want to paste it into your IDE, if you want to put it in a file, it's totally up to you. Okay, so when we run this, we're getting 8109. Let's see if that's the right answer. All right, good stuff. We got another star. Let's take a look at part 2. So part 2 is very similar. We want to do something that's pretty close to what we were doing in part 1, except instead of comparing the first half of the string to the second half of it, now we're taking groups of 3 strings and finding the character that's common to those. But everything else is now the same. We still want to convert to our item priority numbers and then add those all up. And by the way, I actually want to take this moment to shout out the puzzle creator, because making an input like this that works for both part 1 and part 2 and has just the right number of common items, it can take a lot of care to make something like that, especially when you need so many variations on it. So really nice job. I'm always impressed. Now this might be the first time in this series where the whole functional programming thing becomes a real challenge, because traditionally we might want to do something like a for loop where we have an index that starts at 0, ends at the end of the array, and is incremented by 3 each time so that we can just look at groups of 3 in a pretty straightforward way. The problem here is that this iterator variable is not a constant. We're actually reassigning it when we go through the loop. So that's not really in line with the functional programming principles, so we're not going to do it. Basically, our game plan here is that we're going to divide up the array into groups of 3 rucksacks, then we're going to find the common item for each set of 3, and then we're going to find the priorities of those, and then we're going to add them all up. That part's similar to the last part of the problem. There are a few ways we could divide the array into groups of 3. Basically, what we want to do is the opposite of the .flat array method, but I don't think there's actually a built-in for doing this. So I'm going to use a recursive function, which is a function that calls itself. And this is kind of like one of the functional equivalents of using a loop. So this function is going to take an array as an input, and first it's going to check to see if there's anything in that array. If the array is empty, then it's just going to return an empty array, and that's where the recursion is actually going to stop. If it isn't empty, then we're going to return an array that contains the first slice of 3 elements from that array, as well as the elements that we would get by calling this same function on basically the remainder of the array. So everything that's left after we take off that first slice. And that's actually it. It's a pretty small looking function, but it does a lot. So I realize this could be a bit confusing to look at, so let's actually kind of run through an example of how this would work. So if we had an array that had 12 elements in it, let's just say it had the numbers 0 to 11. Basically, the way this is going to work is it's first going to say, hey, is this array empty? No, it's not. So we're going to return an array that contains that first slice of 3 elements, and then the rest of the elements are going to be whatever is inside the next call of the function for the remaining slice. So we kind of need to evaluate the next call of the function. So this function is now working on an array that starts at the number 3 and then contains the rest of it. So that array is not empty, so it's going to return an array containing 3, 4, and 5, as well as whatever the next call would give for an array that starts at 6. That array is still not empty, so it's going to return an array containing its first slice of 3, which is 6, 7, and 8, as well as whatever's inside the next call. And that array is basically just 9, 10, and 11. It's not empty, so it's going to return an array containing that slice, which is basically everything left, 9, 10, and 11, as well as whatever the next call gives. But the next call is actually being called with an empty array, so it's just going to stop there. It's going to say, okay, I'll just give you this empty array. So now we can start resolving this, and this is where we want to pay attention to the fact that we're using a spread operator here. So we're not saying that we're just taking that whole array, but rather the elements inside of it. So on the last call, we got an array containing 9, 10, and 11, which means that what we're actually going to put in the previous call is just this array containing 9, 10, and 11. Okay, great. So now the second last call had this array containing 2 subarrays of length 3. So those are the elements that are going to go in the previous call. So now that call had 3 groups of 3. Those are going to go back into the first call. And there we have it. So we have this divided up into groups of 3. And that's exactly what we get when we actually run this on our rucksacks array. Okay, great. So now we have some groups of 3 rucksacks. I'm just going to take the first one as our sample group because we want to write a function now that's going to find the common item within this group of 3. We're going to do something very similar to the first part where we converted one half to a set and then went through the other half using .find to get the element that's in that set. Except now, since there are 3 parts, we're going to convert both of the first 2 groups into sets, and then we'll go through the third group using .find to see which item is in both of those sets. Since we want to be working with these rucksacks individually, we want to break up this group into individual strings. So we could do that one at a time, but we could actually just use our destructuring to get them all at once. In fact, we can do this very directly by doing the destructuring inside the function header. So that way we just get the 3 elements we're looking for right off the bat. Now I'm going to use another destructuring to convert the first 2 of these into sets. To find the common item, we want to use the array method find. So we're going to start by converting sac3 into an array because it's originally a string and we can't use an array method on a string. So since we want the item that's in both of these, we'll just say it has to be in set 1 and it has to be in set 2. And then we'll return that common item. Great, so that seems to be working. We're getting the value that we expected from the puzzle description. So now we can finish this up. If you remember in part 1, we were able to actually do all of these operations without any intermediate variables, so I want to try to go directly to that this time. Nice. Okay, so that's giving us the right answer, and it looks pretty nice. It looks pretty readable and concise. We're converting this into groups of 3, and then we're finding the common items in each group. We're getting the priority of those items, and then we're just adding them all together. And we're kind of doing it all in one. Now, before we move on, I just want to clean this up a little bit more because there are actually a couple other areas where we have a variable that we're only using once, so we could be a little more direct about it. Now, it's up to you how you want to do this. You might argue that having the variable in there, even though we're not reusing it, it makes it a little clear what that value represents, but I'm not too concerned about it because we have these comments here. Great, so our code is still working. I think we're probably ready to submit it. All right, so once again, we're pasting this into the browser console with our code to get the puzzle input, and it's giving us an output of 2,738. Let's try submitting that. Yay, we got it. Okay, so we have our second star. There are just a couple more things I want to say about our code. I've been getting a lot of great comments on these videos so far, which I really appreciate. I believe there was one that was asking about this sum reducer and why I don't just add this to my utilities.js. And also, what is in my utilities.js? So great questions. So the first answer is that I'm keeping the sum reducer in the file because I just kind of want to keep this all self-contained to make it easier to paste in the browser console and to just show everything that's inside the code here. But it would be totally valid to import it from utilities, and I think it's a great suggestion. As for the answer to the other question, let's take a look. So the main thing I've been using here is just the sum and puzzle input function, which I'm using to get the puzzle input for when we submit it. Aside from that, there's a lot of stuff here related to transducers, which I briefly mentioned in the video from day 1. I want to get a little more into that right now because you'll notice in both parts of our solution, we've got an array, we do a dot map, we do another dot map, we do a reduce. Every time we do one of these dot maps, we're creating another array in memory that we basically are only using to get to the next step. So if we could do this all at once without creating any additional space in memory, that would probably be nicer. Kind of like a lazy evaluation like we see in some other functional programming languages. So the basic idea here is that we're going to convert all of the maps to reduce and then put all the reducers together into one function. So to convert a map into a reduce, it's actually fairly straightforward. The idea is that our accumulator is now going to be an array. It's going to start off as an empty array, and then on each step, we're going to return a new array containing all the elements of the previous array, as well as the result of performing this mapping function on the current item. So you can see that it still works. It looks a little weirder, probably not as easy to read now, but the point is we can do this conversion to both of our map functions, to all of our map functions. Now the idea behind a transducer is that this is going to be a function that modifies a reducer so that we can sort of chain these all together. So I've made this utility function for just creating a new map transducer. So that's basically a function that's going to modify a reducer in order to put a map on it first. So the way we're actually going to use this is create map transducers for both of the maps we want to do, and then we're going to apply both of those in order to our sum reducer. So even though we took kind of an uncomfortable detour to get here, the actual usage of these transducers is pretty clean. We now are only using one reduce, and it kind of describes what we're doing in pretty straightforward terms. We're mapping to the common item, we're mapping to the item priority, and then we're adding them all up. And we get the same answer as before, except now we don't have any intermediary arrays taking up space in memory. And we can apply this to part 2 as well. Our variable names are getting a little long here, but they're describing what's going on. And hey, look at this. We actually already have one of these transducers from the first part. So there we go. We're getting the correct results and it's pretty efficient. Now you definitely don't need to worry about this transducer stuff. I kind of just wanted to show what it was all about, but I would probably just leave it in this form. I think this is probably best and most straightforward. But I do have an extra challenge for you. For part 2, all of this can be done in a single reduce function. We can replace all of these functions we're using and just do it in one reduce. So that's going to be the bonus challenge for today. Good luck with it. Great job today. Looking forward to the next one. And remember, the first step is believing you can do it. Bye for now.